Well, ladies and gentlemen, they say that the third time is the charm. So let's hope that this works because it's the third time I'm recording this video. I hope I don't leave out any details. It is going on 10 o'clock and I'm trying to get this done for the past hour and a half. So bear with me. I want you to actually start by pausing the video. Sounds kind of silly, right? But I want you to pause the video and actually try these questions before I go through them. And then I'll talk about some important details that are going to be needed to go into activity 11.3. So go ahead, pause, take a walk through the questions. Okay, if you paused, thank you for doing so. I'm going to go ahead and walk you through this now. Make sure you check your answers. If you have questions, just circle them, jot them down if you're not sure, or if I'm not making sense through this video. Okay? All right. Point B here is 4-3. And D is 8-6. So I want you to make note of this right away because this is a really important piece into understanding how it ties into the next activity. This graph is proportional. And we've actually talked a lot about proportional relationships and graphs in our warm-ups for our journal entry. It's going to relate a lot here, and we're going to use this concept going into the next piece. So I want you to recall, let me get some highlighting colors here. I'm going to actually highlight the vertical sides. Now, I don't actually have a triangle for this one, but if I did, this would be the vertical side if I had a bigger triangle. And then I'm going to highlight the horizontal side, which is this. And then if I continued it, it would go to here. Just kind of depends. So when you're working with a proportional relationship, we've talked a lot about in the past that if you divide the y value by the x value, you would get the constant of proportionality. So let's jot that down, that the constant of proportionality is when we would divide the y by the x value, and we actually called that k. So we could take any xy point, right? If I took 4-3, I could take the 3 over 4, and that was my unit rate, or the constant of proportionality. If I took 8-6 and I took 6 over 4, it's also equivalent, 6 over 8. It's also equivalent to 3 over 4, and we called this number the constant of proportionality. So that's essentially the slope for a proportional relationship. You cannot do these steps if it's not proportional. Only when the line goes through the origin can you take the y value and divide it by the x value. Now we're going to use this idea here to check whether or not these other points are on the graph. Now I cannot see if 2015 falls on the line, but I can check for a proportional relationship. So I know that if it falls on the line, the slope triangle has to be equivalent to the side lengths of the other triangles that I have shown, right? So the 3 and 4 is coming from this small triangle. So BC right here is 3 and AC is 4. That's essentially y over x in this situation. For the larger triangle, 6, and then on the bottom here, that's 8. It's also equivalent to 3 over 4. So that quotient is what's allowing me to determine if relationships are proportional, other points. So 2015, let's take that. I have XY value. So my Y value is 15. My X value is 20. That indeed is equal to 3 over 4. So yes, that point is somewhere on that line. I just cannot see it. Let's go to number 3. Let's take again the the Y value is 75. The X value is 100. That also is equal to 3 over 4. So yes, that point lies on the line. Let's go to number 4. 90, 68. My y value is 68, or my vertical side of the triangle, and my x value, or my horizontal side of the triangle, is 90. But now that is not equal to 3 over 4. So no, that point does not lie on the line because it is not a proportional relationship. The quotient, so let's again just kind of reiterate that piece. I'm going to color code it. The vertical distance, or the vertical change, over the horizontal change represents the slope of the line. And all the points that lie on the line have to be equal to the same slope in order to make that decision or to determine it. Now, number 5 talks about write a rule that would allow you to test whether the point is on the line or not. Well, we talked about anytime I take the y value and divide it by the x value, I can determine if it has the same slope or not. That is essentially my rule. When I take the y value and divide it by the x value, it has to be equal to 3/4 for this line. Now, if it was maybe a different slope, then I would say it has to be equal to this slope. But this only works because this is a proportional relationship. It starts at the origin. The next problem we do is not going to start at the origin, so it's really important to take these key pieces away. You can only divide y by x if your line is proportional. If it is not proportional, we're going to learn to do something different in the next video.